In the last class, we have studied about the steps for converting a context-free grammar to grayback normal form. So in this class, I'll explain it with one example problem. So here you can see that a context-free grammar is given, that is S gives CA or BB, B gives B or SB, C gives B and A gives A. So this is the grammar that is given. So we are going to convert this grammar to grayback normal form. So we will study it by the steps one by one. So the first step is checking for epsilon productions and unit productions. So we have to check in our grammar whether any epsilon productions and unit productions. So in the grammar you can see there is no epsilon production and also there is no unit productions. We are having single terminals only, but we are not at all having any single variable. So we can directly go to the second step, since our grammar is not at all having any epsilon productions and also the unit productions. And the second step is we have to check whether the context free grammar is in CNF. So we know what is the format for the grammars to be in CNF. So it should be A gives A, that is a single terminal, or A gives BC, that is a set of two variables. So if we can say that a grammar is in CNF, that is Chomsky normal form, whether if it is having a single, the production should have a single terminal or two variables. So that one is said to be a Chomsky normal form. So if it is in Chomsky normal form, we can go to the next step. So in the given grammar, you can check whether it is in Chomsky normal form. So here we are having two variables, here two variables, here was single terminal, here we are having two variables, single terminal and single terminal. So we know that definitely the given grammar is in Chomsky normal form. So we can directly go to the third step. So the third step is renaming the variables. So what we are going to do is, whatever the variables that are given in the grammar, we have to rename it. So what are the variables that are given in our grammar? S, C, A, B. So these are the four variables that are given in our grammar. So we have to rename it in order. So we are going to give A1 for S, and we are going to replace A1 with S with A1 and C with A2, A with A3 and B with A4. So in this way we are going to rename it in order. We have to do it in order. So you can see here renaming the variables, replace S with A1, C with A2, A with A3 and B with A4. Okay. So now we can see how we can change our, how we can rename our grammar. So I already said that replacing S with A1 and C with A2 and A with A3 and B with A4. Okay, so how can we write our grammar? What is S? S is A1. A1 gives, what is C? C is A2. A2, A3 or A4, A4. Okay, then the second one, that is B. B means A4 gives B, or what is S? S is A1 and what is this B? B is A4 again. Then C gives B and what is this A? A is A3 gives A. So this C is A2. So A2 gives B. So in this way, after renaming our variables, our grammar will be like this. Okay. So after renaming the variables, our grammar will be like this. Then we are going for the next step. The fourth step is we are going to check whether AI less than AJ. So we are going to check whether AI less than AJ. So if I less than J, that is AI less than J, we are keeping the productions as such. So if I greater than or equal to J, we are going to change the productions. So we know that if I greater than j, we are going to change the productions, and if I equal to j, we know that the left recursion occurs there. So if left recursion is occurring there, we have to eliminate the left recursion also. So now we are going to do the fourth step. First I am taking the first production, that is A1 gives A2, A3 or A4, A4. So first I am taking the production A1 gives A2, A3 or A4, A4. So we will check whether I less than j. So in the variable A1 I is 1, and here we are comparing A1 and A2. Okay, so I less than j. Okay, then we are taking A1, A3. Now I is less than j. It is okay. Then we are taking A1, A4. Now here also I is less than j. So in the first production we are keeping everything as if we are not at all going to change any productions there. Then we are taking the second production, that is A4 gives B or A1, A4. So we are going to take A4 gives B or A1, A4. Now we will check whether I less than j. So here what is we are comparing A4 and A1. So here I greater than j. Okay, so we have to change the production. Then here we can see A4. So I equal to j. So this one also we are going to change it because left recursion occurs here. So we are going to change the production also. Okay, so here you can see. So what we should do is we are going to replace the A1, this A1 using the productions of A1. So here A4 gives B or A1, A4. So we know that I is greater A4, and while comparing A4 and A1, I is greater than j. So what we should do is we have to replace this A1 using the productions of A1. So which are the productions of A1 is A2, A3 or A4, A4. So we are going to replace A1 with the productions of A1. So here you can see we are writing A4 gives B, and which is the production of A1. A1 is A2, A3, and then we are writing this A4. So A2, A3 in the place of this A1 we are writing, and the first production A2, A3 and this A4, or we are writing in the place of this A1 we are writing this A4, A4. We are writing this A4, A4 and this A4. Okay, so now again what we are going to, I think you can able to understand this one. So since this I is greater than j, what we should do is we have to replace this A1 using the productions of A1. So what are the productions of A1 is A2, A3 or A4, A4. So we are going to replace this A1 with the productions of A1. Okay, so I am writing the grammar. A4 gives B, A1, A4. So in the place of A1 we are writing the first production of A1, that is A2, A3 and this A4, or we are writing in the place of this A1 we are writing the second production of A1, that is A4, A4 and then this A4. Okay, now we are checking, now we are going to check whether this I is less than j. Now also for this one also we are going to check whether I is less than j. Okay, we will check. So here you can see while comparing A4, A2, here I is greater than j, and this one also I is greater than j, and here I is equal to j. So again left recursion comes, and then okay, here you can see that A4, so here both sides it's starting with A4, so I equal to J, so definitely here we are having left recursion, so we have to eliminate this left recursion also. So now we are going to do what we are going to do is we are going to substitute the value of B here. So what is B? The production of A2 is B. We are having the production of A2 is B. So we are going to substitute it here. So you can see A4 gives B. So A4 gives B, or what is this A2? A2 is B again. So A2 gives B. So we are giving, instead of A2 we are writing B, A3, A4, and then the remaining productions A4, A4, A4. Okay. So here we are having B, A3, A4. So you may think like here also again I is greater than J, but we know that what is the standard form of Grayback normal form is a single terminal or a terminal that is followed with set of variables, right? So in this case, this particular production is of the form a single terminal that is followed with variables. So in this case, if it is coming in this way, means we can say that this is definitely in GNF, and why we are saying that it is in GNF is the terminal that is followed by the non-terminal or the variables. So definitely we can say that this is in GNF. So we have to change this one only. So here you know that left recursion is there, so we have to eliminate that left recursion. So we know that the first production and the second productions are in GNF, so we are not at all going to do any changes there, and we are going to consider this one only, the third production. So here you can see A4 gives A4, A4, A4. So here you can see that I equal to J. So this is left recursion. So we are going to eliminate left recursion also. So if you are having any left recursion, we have to eliminate that also. That is the fifth step on the conversion of context-free grammar to Grayback normal form. So how we can remove the left recursion? So we can remove left recursion by introducing a new variable. So we can remove left recursion by introducing a new variable. So we are writing the production as such. A4 gives B, or B, A3, A4, or A4, A4, A4. So this one leads to left recursion, right? So instead of this one, we are introducing a new variable, that is Z. So we are introducing a new variable Z, that is the how can we write the productions of Z is Z gives A4, A4, so the first symbol, second symbol, and the third symbol, that the last symbol is replaced with the production symbol. So in this way we have to write, we are introducing a, so after left recursion, if we find that our